So I figured that you guys would be my guinea pigs. Okay, figured you'll be my guinea pigs this morning with testing this camera. So, hi people watching this.
Hi.
You guys that
Hi.
Yeah.
I don't think Maddie wants to be in the camera angle.
30 million people.
Okay, fine. First thing on the agenda is need to know. So, you guys asked a great question this morning about what you didn't understand with the time on the parabola. Are there other things after yesterday that you were struggling with or that you really want to know or ask questions of, especially since I wasn't here yesterday? Think about that letter.
Do you have any questions?
Yeah.
Yeah. Okay.
Okay, so finding the velocity of each second, we just do normal velocity distance divided by time, right? There's no
Yeah.
fancy that we have to do
Yeah,
that.
yeah. I love that. We've done a lot of practice so far with. Let me launch this here quickly. We've done practice where we've talked about how to figure out the distances, but I really haven't discussed the speeds going up. But I think you're going to find it's exactly what you said, and it's pretty straightforward once the board loads here. Do we all remember what the acceleration due to gravity is? 9.8 meters per second. There you go. So, if I asked you, I need you to draw a parabola for me. You drew that beautiful parabola. And I said, okay, the object starts its motion right here. Let's just say this object is, I don't know, a small squirrel.
What's up with squirrels?
Good squirrels.
And in 1 second, the squirrel is here. In 2 seconds, the squirrel is there. We'll say that this is nice and even. It's 2.5 seconds here. Oh, it would be the time right here.
3.
3, good. And then here it would be
4.
Quinn. Who said 5? Quinn?
No.
Thanks for testing this. She was just testing this.
Yeah.
Yeah, she was just testing this. Right. Why is it 4 right there? Brett?
Because 4 comes after 3.
4 does come after 3. I'm glad we're paying attention today. Why else does the 4 go there in that particular location? Go ahead, Audrey.
Because there's a 1 second interval between the 1 and the 2 seconds, so you have to have the same on the other side.
So you notice an equal interval between here and then between these 2 points. And what was that algebra 2 term that allows us to make that conclusion? Mr. Phillips has his fingers crossed right now.
Uh-oh.
I know Audrey knows, so I'm going to pass on her for a second. I want somebody who has it. Go ahead, Joey, go ahead. Yes, man. Somebody give that man a high five. Axis of symmetry. Thank you. What does axis of symmetry mean? Haley?
It means they're the same on both sides, like the parabola is the same.
So it's like a mirror image, right? On one side of it. Great, so that's how we can do that. So, we can finish this. 5 seconds would be back here. This would be, we'll just say it's 0 seconds. Alright, this small squirrel. Megan, how fast do you want this small squirrel in meters per second going up in the air?
269.
Give me a number between 50 and 52. No, just kidding. What'd you say? Oh, okay, gotta be fast. Now, give me any number you want.
Any number?
Yeah, preferably easy numbers. What was it?
12.
12? You go a little bit higher than that.
A little bit higher?
Yeah. What? 24?
40.
40? 40 it is. That was, I know I said any number you wanted, and then I decided not to take that number. It's all good.
4.08 seconds is like the count.
40 meters per second up. Okay? So one of the questions that came up in that letter that you got yesterday, and I did rearrange the questions last night. Was anybody on the document when I was rearranging things last night?
I saw some of
I was on a document, but I wasn't on my computer.
Some of you were on the document. And so I actually typed a message to everyone on top of the document. Let me just show you real quickly here. I rearranged the question order to try to make it make more sense. Originally had number 1, I think, as number 3 or something like that. No, 1 was 2, 2 was 3, 3 was 4, and 4 was 1.
Yeah.
And I rearranged it to try to make it match more of the pattern that we did in class. And so what I did is I said, first of all, let's just start like we've always done and just figure out what's the time at the top. And then number 2 is out height at the top. And then number 3 is, okay, let's start figuring out the distances at these different intervals, like we've been practicing. But number 4, I really haven't asked you to do that yet. And I think this is what your question was, right? Is, okay, if we figured out that it was, probably writing with this on this dry erase board isn't going to work, is it?
No.
Okay. If we figured out in the warm-up question this morning that at 3 seconds it was 35.3 meters, what I haven't asked you is what's its speed at that point? And that's what question 4 in the letter is starting to ask. So I'm glad somebody brought this up. In fact, I was kind of hoping somebody would. So, Jake, what do you know?
So I know that there's an axis of symmetry.
Oh, yeah?
I think that goes for speed too, is that right?
Sure, yep. So,
So,
let me just go back to the smartboard here, so I can ask you to elaborate on that. So, what's the acceleration due to gravity?
10.8 meters per second squared.
9.8 meters per second squared. What's that mean, Jake?
It means that gravity is pulling the projectile down 9.8 meters a second, and then you have to square it. I don't know.
So, yeah, so I would say you're 90% there. Okay, so what you said was correct, and then the part you don't know is what that says is every second gravity is pulling down 9.8 meters per second. So that's where the squared comes in. Every second, 9.8 meters per second. So there's our 2 seconds there. Okay? So originally it's 40 meters per second. It's going up in the air, but gravity is trying to pull it down 9.8 meters per second every second. So what if we go in feet? So what's 40 minus 9.8?
38.2. 31.2.
Or no, 30.2.
We're just gonna use the calculators that we have.
Yeah, that's fine. Let's just
Okay.
make sure.
30.2.
30.2? You agree? Okay. That's the speed at 1 second. Because 1 second into its flight, because the only force acting on that small squirrel is gravity. And gravity, as long as you stay on Earth, please stay on Earth the first day, is always at the same rate of acceleration, 9.8 meters per second down. Every second it's going up, it's decreasing by 9.8 meters per second.
Wait, that's not taking into consideration air resistance.
Correct. We are ignoring air resistance. Very good observation, Clint.
So would that mean 4 is also the same speed?
That's what I was thinking. Wouldn't 4 be the exact same speed?
Because if Jake said that the speed.
Okay. So Jake mentioned axis of symmetry, and so Brad and Aaron are quick to say, well, would that mean that at 4 seconds it's 30.2 meters per second? Who would agree with that? Mr. Phillips does. That's a good sign, right? Okay. So we could go ahead and pencil this in here. Now, what's the difference, though, between 1 second and 4 seconds? Somebody not named Aaron.
Dude.
I'll get you a better one. Okay. Maddie?
The difference is the fact that it's already gone up, so it's like as you go up, you're kind of like trying to you don't have as much speed as you will going down because the gravity is pulling on it.
Well, we could look, though, and see the speed right now is the same in both of these instances, right? What's the only difference as far as the motion of the swirl is concerned? One's going up,
The other's coming down.
one's going down.
Oh,
Because velocity is a
Vector.
yeah, good, excellent. Velocity is a vector. So we can't forget direction is important. So same magnitude but different direction. So this one is going up, and this one is going down.
Would that make one of them negative?
You could write it as a negative. Yeah. We would have to identify what we consider the positive direction. We might consider up being the positive direction, in which case 4 seconds would be negative 30.2 meters per second. But as long as you clearly state it, or it was told to you what it should be, then yeah, you can put one as positive or one as negative. Good. Excellent. What about 2 seconds?
Wouldn't
Wouldn't you just do 40 minus 9.8 times 2?
Well, we know at 1 second it's 30.2. So why are you so adamant about 20.4?
Because it's 30.2 minus 9.8.
So we take away another 9.8 meters per second. What was it again?
20.4.
20.4.
And that's our speed for 3 seconds.
20.4 meters per second up. So you see, just keep taking away 9.8. Take away another 9.8 every second. That's what 9.8 meters per second squared means. Specifically, that's what the meters per second squared means. That second squared, every second, you lose another 9.8 meters per second.
Okay, so my question for you is at 0 seconds, say that we're at 0 seconds and 5 seconds, it would be the same speed as well, right?
Theoretically, ignoring air resistance.
Okay, so if it went 6 seconds, say I was throwing it off a cliff, I would just add another 9.8 to that? Okay.
Yep. If you were thrown off a cliff, so Aaron's observation was if it's 40 meters per second up at 0 seconds, what is it at 5 seconds?
40 meters per second.
Because now it's gaining 9.8 as it's coming back down. His question was, for those who might not have heard, what if this was a cliff and this wasn't level ground right here at 5 seconds? So let's say we were throwing it up towards squirrel. I'm sure it has a parachute. Off a mountain.
It's a flying squirrel.
It's a flying squirrel. Okay.
That's why it's fun.
Now, we would be hard to ignore air resistance then, though. Yeah.
A little bit.
Center nose dive.
Yeah.
Is it?
He's a diver. Alright?
Is it?
He's diving into the water. But if this was a cliff, and so that this squirrel could keep going down further than just 5 seconds, he would gain another 9.8. So it would be at 49.8 at 6 seconds.
Shouldn't we also pencil in number 3 because we have number 2?
Yep. What would it be, Bradley?
20.4.
So if you wanted to figure out, like, at, what is it at 5.5 seconds, you do 9.8 divided by 2
Yep.
and add that to
Yep.
40.
Yep. As long as we're on Earth. I go to another planet and gravity's different, so then it'll be a different value than 9.8. And then, of course, there's that mean physics teacher that gave you that letter yesterday, and it was, you know, your initial velocities were feet per second.
Yeah.
Yeah, we decided
We'll
that
talk
we're
about that
gonna,
next.
we decided we're gonna do everything in meters, and we're gonna convert everything into feet.
Okay, fair enough. Marcus, you're thinking. I see the wheels turning.
I don't think it's relevant.
Okay.
You'd have to lose 20.4 meters, like 20.4 meters per second in 0.5 seconds, and then gain it again in 0.5 seconds. Is that?
Wait, what?
Yeah.
To get
When
to
you
the
hit the
top
top,
in that
doesn't
amount of
No,
time.
your speed doesn't necessarily stop.
I thought it had the
But
for it to
see,
come back
this
down.
isn't the distance. This is the speed. So you could still be going. That's why it's a this and not this.
Well, at 2.5 seconds, so wouldn't you lose?
At 2.5 seconds, your speed is 0.
Yeah.
It's not on a scale. Well, it's we picked 40, right? We drew the parabola and then we picked the starting velocity.
So it's arbitrary at this point.
Yeah.
That's why I said
But I like the way you're thinking.
that's
Did
why I
you-
said it's
that's-
probably not relevant.
But that's great, though. That's the type of thinking you should be doing here. I love that. And also, that's the type of thinking that caught mistakes made earlier, too. Right? So that's good. I do sometimes make a mistake. I usually blame McKaylee for those mistakes.
I would
Wait,
too.
she's here.
I do too.
Sorry. Yeah, Harry.
I think we should go outside and throw a ball and then calculate its stopping and then.
I think we should go outside and throw squirrels.
No.
Now,
Squirrels are nice.
I want to add a little bit more to what Aaron was saying. If this was a cliff,
No.
and so the squirrel can keep going
Once by
6
miles.
seconds, 7 seconds, 8 seconds, 9 seconds, maybe it's out of an airplane and just jump up out of the airplane. Alright? That squirrel is going to keep increasing by 9.8 meters per second every second. Agreed?
Until it reaches terminal velocity.
Oh, beat me to the punchline. Don't forget about terminal velocity. Remember that? At some point, depending on the size, the mass and the shape of that object, it's going to reach what we call terminal velocity and it'll stop accelerating because the air resistance becomes so great that it'll cancel it out.
So, as it's reaching terminal velocity, how would you continue to calculate that?
Well, calculations get a little bit trickier with air resistance figured in, but
That's why we're not using it, right?
so we're not going to go there this year
Thanks.
right now.
Thank you.
You're welcome, but it is possible to figure it out.
It's just really, really difficult.
It would just be a lot more sophisticated math than we need to do with algebra 2. But I'm sure you guys can. If you really want to know, I'm sure that Josh would be happy to teach you.
Mr. Roy?
He's like, nah, I would rather just keep this information.
Mr. Roy?
Yeah. You got it figured out, right?
No, I have something for you.
Okay, what is this? Uh-oh. What do you got here? He's got that is, speaking of launching squirrels, no, literally launching squirrels. Do we have any other questions that have come from this discussion?
No, sir?
Okay. What I will do is transition then. I want to ask you how you feel about that problem with feet per second and meters per second. Now, it sounds like some of you have figured it out.
Because we decided we wanted to use the same measurements like in feet. We wanted to stick with a document, but we figured it was easier just to use like Google to convert the feet into meters, do all the measurements in meters, and then when we're done, just convert it back to feet to Google.
Yeah. I'm going to scan this and I'll link this into the agenda. So in the agenda document, right where it says, or the agenda document, where it says feet per second versus meters per second, that'll be this piece of paper. I'll link that in there after I get done talking today. So you don't need to write anything down that I'm about to do for this moment, but pay attention, make sure it makes sense to you. Capiche? Okay. Let me go back to the smart board for a second here. So keep in mind that if we have a velocity in meters per, or I'm sorry, in feet per second, so I'm going to say if the velocity is in feet per second, we cannot use 9.8.
Why not?
Thank you.
9.8 is
It's like I paid you to say that. I did. But why can we not use 9.8, Brad?
Why not?
Because 9.8 is in meters and not feet.
Right. 9.8 meters per second is not feet per second. And what's the problem with trying to use feet and meters together?
meters equal 3 feet, so it's going to be totally off.
Right. They're not the same units of measure, right? Meters is the good old metric system, which we love,
One is ugly.
right? We love it.
And the feet is the wonderful imperial system.
Yeah, or as I call it, the English system, right?
This
And
is
so they
like,
don't jive.
did you see that video that I sent Mr. Phillips? Did he send you
Don't
that
call it
video?
English.
No, I don't think I have
It's a
it.
guy that he literally explains every single measurement in the imperial
Oh, it's
system. It's so hilarious. I'll email it to you. I'll email. Did you?
Yeah.
Oh,
Never did.
oh, we did.
So feet would be the English system, sad face. Meters, metric system, happy face. Oops.
He just.
So sad.
Still thinking about the squirrel falling.
What about the squirrel
Nothing makes me
pen?
happy anymore.
Whoa. You said you're thinking about the squirrel falling. Why would that be a sad face if you said it had a parachute?
Because I miss him.
Why would you throw him?
It was his favorite squirrel and he threw him off a cliff.
You have two choices. And you have to make one of these two choices in order to correctly answer the questions on that letter. Sounds like you guys made your choice. I'm sure others have as well. But I want to make sure we're clear since I unfortunately wasn't able to be here with you guys yesterday morning. The first choice is to change feet to meters. Feet to meters. Okay? And that's not hard to do because you have something called the Googles, right? So you can Google and say, hey Google, how many feet are in a meter, or vice versa. Okay? And I did that, and it said, hey Mr. Verwey, 1 foot is about 0.3048 meters. And I was like, sweet. You know why I said sweet? Because to me I see an equality. That a foot equals 0.3048 meters, which means I get to play stoichiometry. We remember stoichiometry from early this year, at least the word. Yeah, okay, good. I'll take it.
I love stoichiometry.
Alright?
I love Google. Does the
So,
same thing.
can I go over here for a sec? Use this board? Just to change up the scenery a little bit? So, let's just say that you were given 80 feet per second as your velocity. 80 feet per second. Can you see that alright, Keely? Yeah, right big enough? Okay. Alright. Well, if I know that there's this equality here, I can change the feet per second to meters per second pretty easily. You might remember setting up the brackets. Stoichiometry.
Yeah.
And really it's just saying multiply or divide. Do you remember what the vertical lines mean?
Divide.
Subtract.
Try again.
Multiply.
Divide.
Add.
Well, yeah, it's good they were reviewing, right?
Everyone's had it right.
You gotta be right at one point.
I'm crying on the inside, trust me. Nah, it's been a while since we practiced this. It was September after all. Vertical lines mean multiply. Good, very good. Multiply. The easier way to remember is the horizontal lines look like the line in a fraction, agree?
Division.
Okay? And that means division. It even looks like the line in the division sign, right? The division sign has that horizontal line.
Oh, see, I was thinking.
So this horizontal line would always mean divide, this line means multiply. We always arranged our numbers in these problems so that we got rid of the unit we don't want to use, right? We don't want to use feet. We want to get rid of feet. So I have to put something with feet. That sounds like I put a person there, you got feet. I have to put a number with feet as the unit in the bottom. I want to get rid of feet, and I want to change it to meters. So I'll put that on the top. Here's where this equality comes into play. I put the 1 foot there, and I put the 0.3, what was it? 0.48. And what happens to the feet unit? Cancels out. Good. Boom, boom. Now, how do I solve that? Say again?
80 times 0.304,
So multiply the top together, and then we would multiply the bottom together, and we would divide into 2. Now, this is easy math down here.
1s.
There's no number there, so what can you assume that number is?
1.
1. 1 times 1 on a good day?
1.
Good day. So we're divided by 1, so that makes life easy. It comes up to about 24.4, I think.
Yeah, one of the days we should organize the class just on like totally last, something like that.
So now we have a velocity in meters per second, and life is good. So I could go ahead now and say, okay, I'm going to figure out the time of fall, so I can use the good old V equals GT formula, which I know is Lauren's favorite formula. Right, Lauren? Yeah, see? She's proud. She's like, yes, he's using my formula. So I can plug in at 24.4 meters per second. Now I can use 9.8 for the acceleration, solve for time, and I'll just save you the heartache. It's going to be 2.5 seconds. Boom, okay? Second option. Back over here.
You're walking a little too fast. I barely caught up with you.
Yeah, see, the camera hasn't been in shape like I am. The second option would be to change the 9.8 to its English equivalent. Does anyone happen to know what 9.8 meters per second squared is in feet?
Yes, I remember. Is it 32.4?
Yes. We'll just keep it simple at 32.
Okay.
Okay? It's 32 feet per second. So if you want to stay in feet, you would just have to make sure you remember to use 32. Oops, there's a mistake. What's the mistake, Wesley? Would you fix that for me over there? Thanks. I forgot to square the S here. He's on it. Good catch.
Go Wesley.
Perfect. So, if I do that, I want to use 80 feet per second again. 80 feet per second. You see that, Zena? Is that visible to you?
A little bit.
Okay. How about if I draw it down here?
Yeah,
Is that better? And I want to use the 32 feet per second squared. So let's use the same formula. V equals GT. 80 feet per second equals, now instead of 9.8 is 32 feet per second squared. And solve for time. The answer comes out to, what a surprise, 2.5 seconds. So I got the same answer, as long as I use the proper units.
It's just a lot easier to work on meters.
I personally think it's better to use meters, because it's what the rest of the world uses. And then we're also using 9.8, because it's like the second project I've been telling you to start remembering 9.8.
What's funny though is that all the countries.
Yeah, I'm still plugging in 32.
Yeah, well,
It's like.
Always perfect, right?
I like solo metric system, but I like miles per hour more than constant per hour.
Oh, really?
Yeah. I like miles per hour.
I think we're on break.
Yeah, we are.
Yes, we are.
See you in 5.
Do I pause it?
Yep. Let's go ahead and stop.